Hello everyone, this is M. Hemant Reddy. I am from EEE A section. Today I want to say about root locus procedure from control systems course. Root locus procedure in control systems. Introduction to root locus. The root locus is a graphic method used to analyze and design control systems. It illustrates how the roots of an system's characteristics equations changes a system parameter varies. This technique is particularly useful for determining stability and transient response characteristics. Basics of control systems. Control systems are essential in maintaining desired outputs in dynamic systems. They can be classified into one loop and closed loop, open loop and closed loop systems based on feedback uses. The performance of these systems is often assessed through stability, speed of response, and accuracy. This is the procedure of root locus. Root locus method. Steps of construction. First, in step 1, we should locate the poles and zeros of g of s and h of s of the S-plane. The root locus branch starts from one loop poles and terminate at 0. Determine the root. In second step, we should determine the root locus on real axis. Moving to third one, we should determine asymptotes of root locus branch and meeting points of asymptotes with real axis. And in fourth step, we should find breakaway and break-in points. Breakaway points. In step 5, if there is a complex pole, then determine the angle of departure from complex pole. If there is a complex zero, then we should determine the angle of arrival at complex zero. In step 6, we should find the points where the root locus may cross the imaginary axis. In step 7, we should take a series of points in the neighborhood of the origin of the S-plane and adjust the test points to satisfy angle of iteration. Sketch the root locus by joining the test points by smooth curves. Formulas. These are the formulas for angle of asymptotes equals to plus or minus 180 into 2q plus 1 by n minus m, where n equals to number of poles and m equals to number of zeros. Centroid equals to sum of poles minus sum of zeros by n minus m. Angle of departure equals to 180 minus sum of angle of vector to complex pole from the other pole plus sum of angle of vector to complex pole from zeros. Angle of arrival equals to 180 minus sum of angle of vectors to complex 0 to all other zeros plus sum of angle of vectors to complex zeros from poles. Characteristic equation. The characteristic equation is derived from the closed loop transfer function of a system. It typically takes the form of 1 plus g of s h of s equals to 0, where g of s and h of s are the forward and feedback transfer functions respectively. The root locus of the equation are the poles of closed loop systems which are critical for stability analysis. Root locus rules. There are specific rules that govern the construction of the root locus plot. The number of branches in the root locus is the number of poles in g of s and h of s. The root locus starts at the open loop poles and ends at the open loop zeros as the gain increases. Plotting the root locus. To plot the root locus, one must first identify the poles and zeros of the transfer function. The segment of real axis that belongs to the root locus can be determined using the angular criterion. Software tools can also be utilized to aid the visualization of the root locus. Stability analysis. The root locus provides immediate insight into the stability of a control system. If all poles of the closed loop systems lie in the left half of the S-plane, the system is stable. Conversely, poles in the right half of indicate instability, while poles on the imaginary axis suggest marginal stability. Designing controllers using root locus. Root locus techniques can be employed to design controllers by modifying system dynamics. By adding poles or zeros, one can shape the root locus to achieve desired performance specifications. The desired approach helps in turning parameters for stability and response times. Conclusion and applications. The root locus method is a powerful tool in control system design and analysis. It aids engineering in visualization system behavior as parameters change, facilitating effective decision making. Its applications snap multiple fields including robotics, aerospace, and automotive systems. This presentation structure provides a comprehensive overview of the root locus procedure in control systems, suitable for educational and professional purposes. Thank you.